Today's repair, I have a control board from a device which is used to start car motors. So it's kind of I would say a bit beefier car battery charger, and it weighs about 150 kilos, so I couldn't take it with me home to repair. But I took the control board. I will repair the rest of it on the field. This is the board, and it is from 1988, third week 88, and then there are mentions of 88 all over the place. So this board and this probably thing comes from 1988. Yeah, vintage. This control board, it has control circuitry to check the temperature of the heatsink, where the rectifiers are, and also there is a relay, a thermal relay, which checks the temperature of the leads coming into the load. I will show you the device itself later in the next video, because like I said, I couldn't take the whole thing home. Anyways, this thing, it was sitting for years and nobody was using it. My father got it as a gift, but it was broken. And I took this control board to check what may be wrong with the board itself. And here's what I found. A bit of how it works. So we have a rectifier, there's a small transformer, well, quite small transformer, feeding voltage into it, and this is only to power all of the control circuitry. And then we have these chips. This chip, it's actually a voltage stabilizer, which I'm not sure, it's adjustable, so I'm not sure what voltage this circuitry runs on. Then these chips, this is a Russian analog of 555 timer, and this is supposed to be the same chip. I will show you on this schematic later, but it has a lot more legs. However, if I turn it around, only a few of these legs are connected, like 1, 2, 3, 4, 5, 6, yeah, 6 or so. So it may well be a 555 timer in a different package, or with some minor modifications or something like that. Yeah, and I already took a few components out of it. First of all, in this kind of old equipment, I think it's a great idea to change all the electrolytics, because it's already tens of years old. Here are the electrolytics I took out, the beefy ones, 2200 microfarads at 63 volts. They were held in place, so they were like put in like this, more or less, here. And they were held in place by this clip and a little bit of rubber, like that. And it comes to the opposite side of the board and it just sits in place. I think that's to protect it from major vibrations or something like that. Then there were a few smaller electrolytics. One 10 volts, 200 microfarads. An interesting thing about this one, it was sitting in this cap. I'm not sure why, maybe to protect it from vibration or from leakage or something. And it was sitting right here, like something like this. And it doesn't fit snugly, it's just, I don't know. Maybe it's a vibration protection thing or something. And there was another small one which is obviously damaged, leaking and oxidized and so on. 5 microfarads. It was sitting in here. Then also I tested most of the components except the chips, and the relay clicks fine, it's working. Then most of the resistors are fine except a few. I found one here, R11. It was this one. It's M10, which means in Russian standards it's a 100 kilo ohm resistor. So I had to get a new one of these. And then this tested open. I took it out of the board and it's still open. So, and then there are a few more. There's this one, the white one, and this one, white one. I haven't taken them out yet, but these are 15K resistors, and I checked this one, and it measures 17K. So it has drifted a little bit on the high side. I'm not sure if it affects anything. I will replace them anyways. And then I also took out one diode, which was here. It was like this. It was connected like that. The interesting thing about this diode, I thought it was faulty at first when I checked, because you would expect on a normal diode that the current passes this way, right? Like from here would be the anode and here would be the cathode, and it would go this way. However, on this old Russian diode, it's exactly the opposite. I have found on the internet as well that these old diodes have a opposite marking on them. So this stripe, it's on the opposite side from the modern rectifier diodes. I found a very similar specification one in the local shop, because I thought it was faulty. Then I found out that it's not, but I already ordered and bought the replacement one, a modern one, so I will replace it anyways. But that's an interesting thing to note when you are repairing an old equipment. And there are a few more diodes, which I was at first puzzled about, but they also have this stripe in the opposite side of the diode. So the current is flowing not up in this picture, but down, like from here to here, which is the opposite way from the modern diodes. Another thing I found that was wrong with this board, here was a transistor, like mounted like that, and with a screw. And I tested it, and it has a voltage drop only from base to, I think from base to emitter, and then from base to collector there's a open circuit. It's both ways. I put probes anyway, and it's open circuit, so it's a faulty transistor. I have checked online, cross-reference sheets, and I found that this is more or less the same as this diode, which is BD139. So I'm going to replace it with the new one. And also I'm going to clean this heatsink. It's oxidized and doesn't look so good. And I bought some thermal paste. There was no thermal paste, but I will put some on, and for a better heat dissipation. Now the capacitors, the big ones, I found exactly the right ones, 2263 volts, which are a bit smaller. They're, yeah, and they also of a different shape. They have leads coming down from them, whereas the old ones have leads coming from both sides of them. So I will have to think of some way of mounting them. So maybe I will mount only one lead and then put it this way, and then just run a wire from another lead to the other connection. I will think of something. So I will do these repairs, and then I will show you how it all looks, and then I will try to power it up. I checked the schematic, it powers from 24 volts. Unfortunately I have only 20 volt supply, so I will try that, whether it works or not, and we'll see if anything goes smoking or if everything looks fine. This is how a finished board looks like. I have put in new capacitors, and as I thought, I just put in the wires from the negative side going all the way to the connection from the both capacitors. Then I have also cleaned off with a Dremel and a sanding paper disc. I cleaned off a little bit this heatsink, put a little bit of heatsink compound, and screwed in the new transistor. Then I have also replaced the resistors, the 15K ones and the 100 kilo ohms one. This was open, and this was drifted from its original value by 2 kilo ohms. Then there was another capacitor like this in here. It was long and secured in place, but they don't make them anymore, so I put in a new one and secured it in place with some hot glue, because yeah, I also put the hot glue in here so it doesn't vibrate and off the board or something. And I think this is also for vibration protection. By the way, I have also fixed a trace which was burned. This trace had quite a lot of current flowing through it, and it was burned in the middle, so I scraped it all off and put a new wire in here. This is my power supply, and as I said, it goes from 0 to 20 volts, and it can deliver, oh here we go, it can go from 0 to 20 volts DC, and can deliver from 0 to 500 milliamps current. It has adjustable current and also quite precise adjustable voltage. One thing with this unit, I still haven't got the feet, 2 feet. There were 2 feet and 2 were missing, so today I went to the electronics shop and got myself 2 new feet, and I will install these and see if it fits, and it should be much better when the unit is a little bit higher and it doesn't scrape my table. And yeah, let's do that. By the way, here's a look inside of the power supply. Looks cute, even though it's also quite old. This is the piece of equipment that I'm repairing. It looks quite small in the picture, but it's really big. It's almost up to my waist, and here are the specifications. It's a 3-phase device. It needs a 3-phase main supply, and then its power is 16 kilowatts. It can deliver 12 to 24 volts. Essentially, it's just a very beefy and big 12 to 24 volts power supply. Unregulated one though. There we go. It can deliver up to, it can deliver up to 900 amps. And I will show you in the second video when I go and look at it, how beefy everything is, how big the output wires are, and so on. And it weighs 150 kilos. So here's the schematic of it that I have found online, and so here are the inputs, and there's a big 3-phase power transformer, and then there's of course the control circuitry down here, and then there are 6 rectifier diodes, and let me show you how they look. So this is one of the rectifier diodes. It's 200 amps, 1100 volts. So 1 kilovolt to 200 amps. You can notice though that I have two types of diodes on my table. This is the right one. There should be 6 of this type of diodes. And then what I discovered when I came there to see the device, that there were 2 of these, and then there was one, like there were 2 rows of diodes. So in one row there were 2 of these, and the third was missing. And then in the upper row there were 2 of this kind of diodes, and one was missing. And when I was trying to figure out how this thing works, and I saw this mark, like you see the current flows this way, and the interesting thing was that this was connected to the minus output. And so I draw this schematic of how it is connected, the way it was connected there when I first came to see it, and it was connected this way. Yeah, of course there were 2 diodes missing, so there was just an open circuit here. But I was thinking, okay, how does this thing work? And I couldn't understand until I found the schematic, and I saw that it's not the right way that these diodes are connected on this device. So I thought, okay, plus, the current goes here, and it goes to the plus, and then it comes back minus, and where does it go? How does this thing work? It just has a 1 plus and no minus or something. And then when I came home and saw the schematic, and also I got the part numbers, and in the part numbers it says that there are 6 one type of diodes. There are just 6 that type of diodes. So instead of this, we have this schematic where there are all diodes are the same. So someone inexperienced enough has replaced these kind of diodes with this kind of, which are the opposite type of, like the configuration is the opposite. The current here flows, here it flows this way, and here it flows, wait a second, this way. Well, the opposite. So I understand more or less how this part works. There's the transformer and there are the rectifiers, very simple construction. But then there is also the control circuitry. Let me scroll. Here's the control circuit. And it controls the device this way. There is a thermal relay on one of the outputs, actually on one of the leads of the output. So if it overheats, the relay, as far as I understand, it's normally open, and then if it overheats, it closes, and then the control circuitry does something with it. And then there is another protection mechanism, which is a thermal thermistor, 130 kilo ohm thermistor, and this control circuitry also does something with it as well. And then so if either of them overheats, the control circuit switches off the outputs, and it also switches on the lamp, which translated it means overload. And I was trying to understand how this circuit works and how I can test it here with my bench power supply, and see if I can see if it works correctly here at home, so I don't have to understand that in the field, go there and see if any smoke comes up. So I thought, how can I connect it and how does it work? So these D2 and D3 are 555 chips, and this one is the voltage stabilizer. And so I'm not really sure. I may link this schematic down in the description so someone can see and maybe explain to me how all of that works. Okay, so I'm trying to understand how to connect it and how to test it. So as far as I got, there's this relay K3, which is actually this one, and I have tested and it works. And it controls both the light, overload light, and also this contact here, which I guess somehow through these contacts and relays switches off the output if there is an overload. So normally, let's see, normally when the relay is switched off, the contact here is closed, so the light overload glows and there is no output, of course. And when the relay switches on, this relay, then this connection, as far as I understand, is open, and the light doesn't glow, and the outputs can be used. So I was thinking how to test this circuit. So I thought maybe I will connect instead of the light and the transformer, I will connect an LED to my supply through a resistor and to these contacts of this relay, and see if it glows or not. And then instead of the thermistor, which I don't have, which is 130 kilo ohms, I will connect a variable resistor, potentiometer, and set it to about 130 kilo ohms, and then adjust it and see how the circuit behaves. And then there are also here two switches. Let's see. There's S3 is a black one, so I think it's the on switch, soft on switch, and then S4 is the red one, which is probably soft off switch. So S3 is on. So when this one is on, which is in its closed position, so it's a closed circuit, then everything should work and there should be no light overload. And then when this switch is pressed, I guess the outputs should be disabled, and I'm not sure what happens exactly then. I was trying to figure out how this all this circuitry around this 555 timer works, and I just couldn't. I did watch a few videos on 555 timer and how it works and so on, but I just can't figure out how exactly this circuit controls the output from this, judging from this thermistor. And there are a few potentiometers, R4 and another one R7, and I'm not exactly sure what they do. I would like to figure that out, because here they are. Maybe they control the temperature. Like most likely it's in circuit with the thermistor, so it's probably for the control of temperature. And the other one, I'm not sure, it's probably controlling the voltage for this circuit or something. So here's my test setup. I have soldered the potentiometer, and I have preset it to 130 kilo ohms, and I have soldered it to the points let me show you. I have soldered it the way this thermistor works, is connected. Like one lead here and one lead here. So, and I have preset it to 130K, so it should be about, it should register room temperature or so. Now, I have connected power on this capacitor, plus from this side and minus from this side, C4. Well, I'm going to connect it. Plus is connected and I'm going to connect minus when I want it to work. And then to test this relay and protection mode, I have connected, instead of this lamp, I have connected an LED to my power supply through a resistor. And I connected to this contact, which is normally on, closed, and then if the relay engages, then it should turn off. This light should turn off. So now here's the LED. When I turn on the power supply, this glows because it is always connected when there is no power. And then when I switch the circuit on, it should, if everything is set up correctly, I think so, it should stop glowing. But this is first time I'm doing it, so let's see. Let's try to connect it and see what happens. 20 volts connected. And the LED doesn't glow. So that means that the relay has engaged and the protection mode, the overload protection mode, is off. So let's the thermistor, it is 130K NTC type, I think. So when the temperature rises, the resistance should decrease. So I will try now to decrease my potentiometer resistance. I have wired so I turn it counterclockwise to decrease it, and see if the protection, overload protection light comes on at some point. Here we go, it's on. So that means the thermal protection works, and it means that this circuit works. So I'm going to increase it again. There, it's off. And I don't doubt it's about room temperature. So this protection works. Now another step to test is this thermal relay. I don't think this is exactly the right schematic. Most of the components they check out. They are all fine and the right values compared with the parts list and with the PCB, but there's this part where this thyristor is. I can't find where this connection is. Like I'm looking for the pin 14 at D1, and there should be a resistor connecting the other end, one of the ends of this thyristor. And let's see what's on the pin 14 on the chip D1. So this is D1, and pins go this way from 1 to 14. So 14 is here. And let's see, pin number 14 is, let me show you.